Good morning. I'm Dr. Ari Sobando. I'll be presenting the DOST CRADLE project entitled Development of a Design Guideline using Finite Element Analysis for Semiconductor and Electronics Packaging Systems for Automotive application. This project is we're partnered with Integrated Microelectronics, Inc. According to Bloomberg, in 2030, there would be a huge demand for autonomous vehicle. There would be 4.2 million units needed by that time. What are autonomous vehicles? Autonomous vehicles are also known as self-driving cars or driverless cars. Autonomous vehicles are upgraded cars that are capable of sensing its environment and moving safely with little or no human intervention. Autonomous vehicles require various types of electronics and sensing devices. You would see in this figure that there would be different types of sensors, controllers, and other semiconductor products that comprises the autonomous vehicle. What are semiconductor packages? Semiconductor packages consist of various materials where it protects the integrated circuit. Package also provides an electrical connection to external environment. In this project, we use FEA or Finite Element Analysis to design and evaluate the reliability of the package in an autonomous vehicle. What is FEA? FEA is a simulation tool that uses mathematical formulas of physical phenomena. We use FEA to describe the stress behavior in a semiconductor package to further enhance the reliability of the device. In the Philippines, it was mentioned that electronic products remain the country's top export. It amounts to about $3.47 billion in 2019, according to CEPI. And electronic devices, as mentioned, are seen in autonomous vehicles. In this project, we partnered with Integrated Microelectronics, Inc., which are located in Laguna Technopark. The thermomechanical analysis laboratory is actually located in De La Salle University, Laguna campus. And through the DOST CRADLE project, we were able to open this laboratory to support the operations and the design of semiconductor package with IMI. Here's the team, project team for De La Salle University. And for IMI, this is being headed by Mr. Enrique Sonoy Jr. The objectives of the project, the general objective is to be able to boost the development of semiconductor electronics packaging system by providing advanced engineering simulation using finite element analysis under thermomechanical loads. So we try to solve various types of packages, sensors, or even cameras in an autonomous vehicles and be able to improve the design through reliability testing in the simulation environment. Here's the methodology. We first characterize the materials, develop the database for the material properties, create the geometry, and establish the boundary conditions. Then we try to develop its mesh. Then once we have the result, we try to analyze this and be able to come up with solutions, optimal solutions, and recommendations for IMI. Here are some of the project outputs. So we were able to come up with 5 Scopus Index publications out of this project. And we also have 5 students who presented in an international conference. Just to give you an idea, we had our project launching early this year, as shown here. And here are some of the project meetings with IMI. Next steps, we would create an ISI paper together with policy brief. And we are also tasked to develop a website, which we would be launching within this month, and develop an FEA webinar for students and the industry. And that ends my presentation. Thank you very much.